The National Electrical Code, specifically Section 334.103, prohibits the installation of NM-type cable in wet or damp locations unless the cable is specifically listed for such use. However, Section 334.10 states that NM-type cable may be installed in outdoor locations where exposed to weather if protected by a raceway. It's important to differentiate between a wet or damp location and an outdoor location protected by a raceway. When NM-type cable is installed inside a conduit outdoors, it is generally not considered a wet or damp location because the conduit provides a degree of protection from moisture. The interpretation of the authority having jurisdiction, or OJ, may sometimes differ from the standard interpretation of the code. It's not uncommon to install an NM-type cable in conduit outdoors, especially for air conditioning circuits. This practice is generally supported by the National Electrical Code when the conduit provides adequate protection from the elements. If there's a disagreement with the AHJ, it's advisable to first discuss the concerns and provide the relevant National Electrical Code provisions. It can be helpful to have a clear understanding of sections 334.103 and 334.104 of the National Electrical Code. If the AHJ remains unconvinced, consulting with a licensed electrical inspector or a National Electrical Code expert may provide additional support. An alternative solution is to use THWN conductors inside the conduit for the entire circuit. THWN conductors are specifically rated for wet locations. However, this option might be more expensive and require more time compared to using NM-type cable inside the conduit. Remember to always follow all applicable code requirements, even those that may not be explicitly stated in the National Electrical Code. It's also important to ensure that all code interpretations are reasonable and based on sound technical reasoning. The conduit acts as a physical barrier protecting the NM cable from direct exposure to rain, snow, and other environmental factors. The key is to ensure that the conduit system is properly installed and sealed to prevent water from entering and accumulating inside. If water were to consistently enter the conduit and surround the NM cable, then it would indeed be considered a wet location, and the use of NM cable would not be permitted. Proper installation techniques include using watertight fittings and connectors to seal the conduit joints and prevent moisture ingress. It's also essential to consider the potential for condensation inside the conduit, especially in environments with significant temperature fluctuations. Condensation can occur when warm, moist air enters the conduit and cools down, causing water vapor to condense on the interior surfaces. To mitigate condensation, consider using conduit bodies with drained holes or installing a breather fitting at the highest point of the conduit run to allow moisture to escape. Furthermore, the type of conduit used can also affect its ability to protect the NM cable. Rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, provide a higher level of physical protection and are less susceptible to damage compared to electrical metallic tubing, or EMT. Non-metallic conduit, such as PVC, is also suitable for outdoor use, but it's essential to ensure that it's properly supported and protected from physical damage. When selecting NM cable for use in conduit outdoors, it's crucial to choose a cable that is suitable for the intended application. NMB cable is the most common type of NM cable used in residential wiring. It has a temperature rating of 90 degrees Celsius for dry locations and 60 degrees Celsius for wet locations. While NMB cable is not specifically designed for wet locations, it can be used in conduit outdoors as long as the conduit provides adequate protection from moisture. The National Electrical Code also addresses the ampacity of conductors in raceways. When multiple conductors are installed in a single conduit, the ampacity of each conductor must be derated to account for the increased heat generated by the conductors. Table 310.15b3 in the National Electrical Code provides the adjustment factors for ampacity based on the number of current-carrying conductors in a raceway. For example, if there are 4 to 6 current-carrying conductors in a conduit, the ampacity of each conductor must be derated to 80% of its original value. Therefore, it's essential to consider the ampacity derating requirements when selecting the appropriate size NM cable for an outdoor circuit. In addition to the National Electrical Code, Local codes and regulations may also apply to the installation of NM cable and conduit outdoors. It's important to consult with the local AHJ to determine if there are any specific requirements or restrictions that must be followed. The AHJ has the final authority to interpret and enforce the electrical code within their jurisdiction. They may have specific interpretations or requirements based on local conditions or concerns. If there is a disagreement with the AHJ, it's best to approach the situation with a collaborative and respectful attitude. Try to understand the AHJ concerns and provide them with the relevant information and documentation to support your position. It may also be helpful to involve a qualified electrical engineer or consultant to provide an independent assessment of the situation. Ultimately, the goal is to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. When installing NM cable and conduit outdoors, it's also important to consider the grounding requirements. The National Electrical Code requires that all metal raceways and enclosures be properly grounded to provide a low-impedance path for fault current. This helps to protect against electric shock and prevent fires. The grounding conductor can be either a separate equipment grounding conductor or the metal raceway itself can serve as the EGC. If using a separate EGC, it must be sized according to Table 250.122 in the National Electrical Code. The size of the EGC is based on the size of the overcurrent protection device protecting the circuit. For example, if the circuit is protected by a 20-amp circuit breaker, the EGC must be at least a 12 American wire gauge copper conductor. The EGC must be connected to the metal raceway at each end of the conduit run to ensure a continuous grounding path. This can be accomplished by using grounding bushings or grounding lock nuts. In addition to grounding the metal raceway, it's also important to ensure that the electrical equipment being served by the circuit is properly grounded. This includes air conditioners, heat pumps, and other appliances. The equipment grounding conductor must be connected to the equipment grounding terminal inside the appliance. The equipment grounding terminal is typically a green screw or a grounding bus bar. The equipment grounding conductor must be sized according to Table 250.122 in the National Electrical Code. When running conduit outdoors, it's also important to consider the effects of sunlight and ultraviolet or UV radiation. UV radiation can degrade the plastic insulation on electrical conductors, causing them to become brittle and crack over time. To protect the conductors from UV radiation, it's recommended to use sunlight-resistant conductors. Sunlight-resistant conductors are specifically designed to withstand the harmful effects of UV radiation. They have a special outer jacket that is resistant to UV degradation. Alternatively, the conduit can be painted with the UV-resistant paint to provide an additional layer of protection. The type of paint should be specifically designed for outdoor use and should be compatible with the conduit material. When installing conduit in direct sunlight, it's also important to consider the expansion and contraction of the conduit due to temperature changes. Conduit can expand and contract significantly with changes in temperature, which can put stress on the conduit supports and connections. To accommodate expansion and contraction, expansion joints should be installed in long conduit runs. Expansion joints are flexible fittings that allow the conduit to move without putting stress on the supports or connections. The spacing of expansion joints depends on the type of conduit, the temperature range, and the length of the conduit run. The manufacturer's instructions should be consulted for specific recommendations. In summary, when installing NM cable and conduit outdoors, it's essential to follow all applicable codes and regulations, use appropriate materials and installation techniques, and consider the environmental factors that could affect the performance and longevity of the electrical system. It's also important to consult with the local AHJ to ensure that the installation meets the specific requirements.